Morning, everyone. Great to see you. My name is Mike Bell. I'm, as Robert said, Group Strategy Director at Ricardo. So I'm going to cover quite a lot today, but give you a flavour of what we're working on. A thread through all of what I'm going to talk about today will be sustainability. We're going to look at a number of electrification technologies and our experience in terms of what we're doing, and I'll finish thinking about the climate environmental impact of these technologies and the transformational change we're going through. Before we talk about that, I'd also like to focus on where Ricardo is working now. So obviously, I'm sure most of you know us from purely our automotive experience, but we now actually operate in quite a range of diverse industries. So we now have a rail business, so looking at systems engineering, functional safety, etc. We have an energy business, environmental business, and we also work in defense and software. So we have diversified the group, and I think it's very interesting actually from our point of view, because what we see is the area of transportation, and that's in its widest sense, plus energy, plus environment, and see these things really coming together. And that's been a really, really important part of the work that we've been doing, because we're starting to bring skills from the other parts to work with the automotive, the rail, etc. So. I think we all know from the presentations today, everyone's, within the transport sector is challenged in terms of decarbonisation, and clearly that is a focus. And in the UK, as we've decarbonised our energy generation, transport is now the number one for CO2 production. So in terms of where we're focusing in this area, we're very much looking around electrification, heavy investment in that area, and also hydrogen. And we, because of having this wider focus within the group, we're also looking really from both the policy side, so supporting governments around the world in terms of what we do, how we actually leverage the technologies, and what to do next in terms of regulation, and all the way through the value chain in terms of then engineering, and then we do niche manufacturing as well. So let's look at some of our electrification technology. We are working in multiple areas, no surprise, covering PEMD, batteries, and when we're doing a lot of the design work, as well as balancing the usual kind of engineering and product design attributes, we're increasingly bringing sustainability into that, and that is driven by our customers. So, in some cases this could be a full life cycle assessment that they want, as well as the engineering work, or it could just be looking at focusing on the components, the materials that we're using, and the sustainability of those. So we're increasingly seeing that coming to us as requirements, and having our environmental capability is really useful to be able to work with the engineering side on especially things like life cycle assessment. We'll come on to batteries and novel motor design we've been working on in a moment. We do recognise clearly that hybrid solutions are also needed today by many of our customers, and obviously there's a big chunk of work still really in hybrid ICE work that we're still doing. I mean, we know, and Ian put some great graphs up in terms of the transition. We see how quickly it's coming, because we see the work and the R&D projects that we're being asked to do by our customers, and so everyone's clear around the transition and how quickly that will move. I think that full move to electrification, we do see. Maybe not passenger car, but we do see fuel cell being part of that electrification journey for heavy duty, maybe off highway, those kind of applications. Also, rail, marine, those things. We have got a couple of aerospace applications at the moment, which are quite interesting for fuel cell. Quite challenging, by the way, but that's certainly an area we are working in. Obviously, batteries much in focus in the media. Our focus really is helping our customers, from getting those requirements, from choosing chemistries, cell selection, etc., through to modelling, and especially around thermal, which is a real challenge around integration of batteries. And that's where our software division, so we have a number of products, for doing a lot of the simulation work, and we've been investing quite a lot around that area because we do see it as that modelling and virtual engineering is a really key part of that. Clearly, other parts of mechanical design, and of course, like we do with our ICE work that we've been doing for many years, we offer a full range of test services. Increasingly, we are doing more development and R&D for customers around 800 volts, above 800 volts. So obviously, right now in Pascal, there's a number of 800 volt architectures in there, but we're already looking at above 1 kilovolt in terms of the direction, and there are many benefits of that. But there's obviously a lot of challenges with power electronics and things that need to be considered around that. We also have our own BMS and software libraries and customization. So it's a great area for us. We've done recently an APC project to look at industrializing niche battery supply. Because we're not going to put in the big gigafactories that are obviously in the news, but if you look at the UK needs in terms of all of the various vehicle manufacturing and development that we do within the UK, a lot of it's actually quite niche. And so we do see small volume supply of batteries as being something that actually plays well into the area of niche supply that we work in, versus supplying volume manufacturers, which is not really something Ricardo focuses on. So also wanted to cover motor design, and I think the UK only motor project is close to my heart. It was something I got off the ground internally, so it's really enjoyable to be part of that. Initially, we looked at a range of attributes that we really wanted to address, and basically we had a kind of TRL, I guess 3-4 type design that we'd done internally, and we wanted to look at how we could take that to production. And we're very grateful to DER for funding that project, or helping fund that project, because it allows us to work on a range of, within the UK, with a number of partners, as you can see on the right-hand side there, a number of partners who helped us with that in terms of how we would actually build a supply chain around that. The motor itself has some really interesting features, we wanted to think about supply chain and some of the risks within it. So we wanted to remove permanent magnets, rare earth metals like neodymium, have many supply chain, and if you see the pricing on it, it's constantly going upwards. So what we wanted to do was say, how could we deliver the same, very efficient, deliver the power, lose the weight, etc., but not having permanent magnets in there. So we're able to work at higher temperatures because we've swapped out traditional copper windings for aluminium. We've got composites in our flux guides, novel ways of manufacturing the stator, etc. So very interesting projects, and we're continuing to work on this. It's a design that was focused initially around power output of 70 kilowatts, but we have two projects now looking at one at about 70 and one at 120 kilowatts in terms of targeted applications, one on LCV, one I can't quite remember, I should do. So yeah, very interesting. It's great to see the work and the funding that has been put into the UK. Speaking from behalf of Ricardo, very grateful for that, because it's enabled us to do things that would have probably spent a long time arguing as to whether we should do this and the risk associated with it. So it's been a great project, and we continue to invest in this ourselves as well. I think it's interesting. I mean, I have also some personal background in connectivity within vehicles, but you know, we see connectivity associated with autonomy, and we very much see connectivity on a vehicle as far wider than that. And for us, certainly there's an awful lot you can do with taking the data from vehicles around electrification components. This particular project was really around batteries and a connected BMS, looking at state of health. And by collecting you know, the data coming back, some standard, actually fairly standard analytics, but then a bunch of training data with machine learning, we're able to really accurately predict the state of health in terms of capacity and internal resistance. And that's allowed us to actually get up to like a 13% increase in the battery life. And we're doing that by basically pushing updates back to the BMS, where we've done the cloud processing. So rather than put the compute within the vehicle, where that becomes very expensive if we want to put loads of data and storage, etc., we're pushing a certain amount of data to the cloud, we're processing it, and then we're putting back down to the BMS updated parameters, which helps it optimize the way the battery's been used to improve the state of health. This slide I wanted to cover because there's much focus on the actual components in terms of batteries, PEMD, I always struggle to say that. But what I would say is, you know, many of customers still come to Ricardo because, and this is a very good example of this, because actually integrating it, you know, there's one thing designing a component. In this case, it was a battery. It started off as actually a battery concept. In the end, it turned out to be a full production. But you realize that there are a huge amount of other skills around the vehicle, around integrating it, you know, from NVH to thermal, to all of these things that sit around it, functional safety, etc. And we very much feel that whilst there is, you know, and we're certainly investing very heavily in these technologies, to really successfully deploy them within vehicles, you need greater capability around, and that's something that you know, we've really got our strengths on. Obviously, you know, traditionally we came from that ICE background, but all of those skills are very transferable. So whilst we may not be focused so much on clean sheet, you know, ICE design, the move to electrification doesn't lose all of these skills. And I think it's an important point when we start thinking about this transition, because skills is a big part of it. So just to kind of wrap up, actually, I said I'd finish in terms of talking about the impacts of this rapid change. And I think, you know, from our perspective, we very much see the need to move to a life cycle assessment approach. So as Ian talked about, you know, which lined it up very well for me, you know, just remove the tailpipe emissions, that's great, but there's a huge amount of embedded CO2. The picture, it's a little bit complex, but the picture on the right-hand side actually came from a piece of work we did for the European Commission, which looked at like 20 different propulsion technologies around a whole different set of road vehicles, looking at the full life cycle impact, including the energy from the fuel sources. And I put this up, it's 2020, so we did it last year, but the interesting thing here is the blue hexagon there, it represents a gasoline ICE vehicle. And as you can see, a BEV and a fuel cell are the green and red, respectively. Now, what you can see on here is, of course, great, in terms of GWP, global warming potential, i.e. the CO2 impact really here, you know, great impact. You know, we remove a whole bunch of other things, PMF, etc. But as you can see, we do start to worsen the area of human toxicity potential, and also abiotic resource depletion, mineral materials. So in those areas, there are things that we need to do. So with everything, it's not a perfect solution. There are things that we need to address. And clearly, the supply chain will be a really important part of decarbonising and taking out CO2 from the embedded CO2. And I think, clearly where those hotspots are, that will be a key focus in the coming years. And I guess, as it got to the end of my presentation, so thinking about the end of the life of a vehicle as well, it's not something we tend to think that much about. But in reality, if we look not just in the UK, but we don't have industrial scale recycling for electrification components. There are a few places doing it, but in terms of, if we think about those graphs that Ian showed earlier and the growth, and then you think about the life of the vehicle, at some point we have a big problem that we need to address. I'm not saying it's not being addressed, but it isn't there right now. I mean, if you think about even power electronics today, which clearly exist in vehicles, we're not doing a great job with them, to be honest. Current shredding technologies still have high losses for strategic materials, so things like gold, silver, platinum, palladium, tantalum, those kind of materials, we're not recovering them well. So there's an awful lot of wastage. So when we increase, that becomes a problem. And of course, second life batteries is really pretty nascent in terms of where we're going. So I think, really, in summary, really positive. Ricardo is working on a whole bunch of technologies in this electrification space, but we really are also thinking about the full sustainability and life cycle of the vehicle and of our designs. So that's me done. Thank you very much.